Good afternoon, and welcome to the virtual chapter, the past virtual chapter on database administration. My name is Julie Bloomquist, and today we're going to have a lecture on efficiently searching schema in SQL Server by Ed Pollack. We are sponsored by Hewlett-Packard. Again, we really want to thank our sponsor for assisting our virtual chapter. There is a large number of virtual chapters available. Just go out to your PASS account and associate with either a physical or a virtual chapter, and you'll get the emails on the lectures which are coming up. When you attend a lecture in person, you are able to answer questions. However, most virtual chapters always record their presentations, and they're on the archive pages. SQL Saturdays are one-day mini conferences. Here are the ones that are upcoming in the different areas around the world. It's just a one-day conference. It's different lecture types, on DBA, developers, BI, and sometimes professional development. But it's a one-day mini conference lecture. Usually the costs are minimal and limited to what the lunch would be. Now, the PASS Summit Conference is coming up on the 26th through the 28th of October with pre-conference sessions on the 24th and 25th. This is the largest SQL Server conference, and until September 18th, it's $21.95, and if you use our code there of VC15FPS6, you'll receive $150 off your registration. For every 20 registrations using our code, we'll be able to raffle off a complimentary summit registration this fall. Again, it's amazing. So if you have the opportunity to attend a SQL Server conference, this would be it. Here's information again about joining a local chapter. And if there is no local chapter in your area, you should consider starting one, and PASS has information which is available to assist you with starting a local chapter. There are lots of volunteering opportunities with PASS. You can send emails in, and you can also send in a nomination for an Outstanding Volunteer Award, someone who's working either with the local chapter or the virtual chapters or just within PASS volunteering. Stay involved. Here's the information on the different websites and Twitter and Facebook. Remember, it is a free membership. And today, like I said, Ed Pollack's talking on efficiently searching the SQL schema in SQL Server. Ed's over 15 years of experience in database and systems administration, developing a passion for performance optimization, database design, and making things go faster. He's spoken at many SQL Saturdays, the 24 Hours of PASS, and the PASS Summit. This led him to organize the SQL Saturday for Albany, which has become an annual event for the New York's capital region. Sharing these experiences with the community is a top priority, and encouraging everyone to take the leap into public speaking and engaging others is a passion. In his free time, Ed enjoys video games, sci-fi and fantasy, traveling, and cooking exceptionally spicy foods. Ed, we really appreciate you speaking today. Once again, this is being recorded and will be posted on our archive page for the DBA virtual chapter. And Ed, I've just passed over to you. I do see your slide deck.
All right, thank you very much. We'll get right into it then. The goal today is to take some rather simple tools in SQL Server that are provided to us, that are free, that are included in all versions, and take those tools and build something very useful with them, something we can take home and play with and customize and make a part of our tool set that we use every day for the work that we do. So with that, let's get on to it. So what are we going to do here today? We're just going to take simple tools and build a search solution. We're going to intro it. We're going to ask why we even want this thing. And we're going to do lots of demos about system views, what they are, how they work on the server level, on the database level. And we're going to build a proc that builds all that together into something useful that we can use to search any SQL Server anywhere for anything. Take some questions at the end, and then we'll finish up, and we'll be on our way. So with that, let's get to it. What are we here for? SQL Server provides us views. They're system views. They're under the covers. You've probably used some of them before or seen them, things like sys.databases or sys.tables. They're provided internally and give us information about almost any part of SQL Server you're interested in looking into. They're included by default. They're in all versions, all editions. They're there for you to take advantage of. And if you're not, you're missing out on something very useful. Tables, columns, database properties, server specs, you name it. There is probably a view that tells you a little bit of information about it. So why do we even care about this? What can we use this for? If we take all this and build some giant search script that's big and complicated out of all these simple tools, why does it matter? And there are actually a lot of great uses for searching SQL Server. For example, if you're in software development, you want to review dependencies before making a change to make sure that the change you're making isn't going to break something that refers to it elsewhere. Perhaps you want to look at altering or removing a table or column, but want to make sure that you're not going to break something that possibly references it or needs to be in sync with it through application, always on, or just other scripts. You might be doing a migration of some sort, moving a database, a server, an object around, and want to make sure that whatever is referencing it gets moved and changed and re-referenced as well. I want to verify if an object's being used or not. That way, if it's not, you can get rid of it and clean up some old stuff. You can do it for research and documentation, to learn more about your server, to document it, to take a tally of what you have out there currently, how large things are, what they're used for, or to maybe a data dictionary sort of application. Or you want metrics. Maybe you're interested in finding out disk space usage, or how many tables you have at any one given time, or how many in a certain schema. All those can be gotten through a little bit of searching. And of course, as data people, we're kind of curious about how things work. So we may simply want to know information about our server and our databases, and this is a great way to find out. So getting right into the actual views themselves, the tools we're going to use today, we're going to talk first about system server level views. And so these are views that exist in system databases such as MSDB or master, and do not exist in user databases. You won't find these in databases you create. They're universal to the entire server. Many features have these views specially for them. We'll use a few of them today, but in general, things you can configure on your own. You can learn about the configuration of a feature like replication. You can learn about how always on is set up, or relationships between different parts of your server. You can learn about your files, your database files, partitions, compression, so on and so forth. Many of these views can be taken by themselves. Select star from the view where something is something, but they become more powerful when you join them together. You can take many system views, put them together, and get an idea of how different parts of your server interrelate, how your server relates to databases, how your databases relate to the server, and so on, or how different servers relate to each other. And again, all these internals, you can search them. You can apply whatever strings or integers, where clauses to them that you'd like to find out information about how they work, and many internal pieces of the server can be searched as well. Things like the plan cache or the buffer cache, parts of the server that you may not know you can search through, you can actually get a lot of information about. And I've talked about this sort of stuff in other presentations. You can go out there and find that and look into it if you're interested. So let's look at some of these views. I've talked for a good 5 minutes, a whole 5 minutes, on some views and what we're going to do with them. Let's talk about how they work and what we can do with them. So here's our management studio. We are in AdventureWorks. Nothing too exciting. We'll be searching the entire server, so we're actually seeing a little bit more. I have a few databases on here on my local server, in addition to the system databases, master model, MSDB, and tempDB. So the first system view we can look at, and one of the simplest, is sys.databases. This view provides information on each database on your server, whether or not it's a system database or not. So we could just do a select from it and get everything, like this, and not apply a where clause. And if we do, we get some results. I put database name and object type first, just for future reference, so we have this information. There's a lot of information here in addition to just the name of the database. The owner is there, the create date, the correlation, the compatibility level, and as I scroll over, you see lots and lots and lots of information. If you're looking for something specific about a database, there's a good chance that it's referenced here, and you can find out more about it. One nice thing about these views is they're very well documented for the most part. If you go onto MSDN or Books Online, you can get quite a bit of information about each of these views, example queries, the data types of the columns, and so on. This is all the databases that I have on my server. We don't have that many. I could also filter, if I'd like, and say, give me everything from sys.databases where the name is like, and then provide some filtering. For example, I may only be interested in a specific type of database or a certain name. I could filter by other information, for example, when it was created or who owns it. If I were to search with the where clause, we get one database. No big surprise, nothing fancy here. You can also search other objects in the server, such as logins. I can say, give me some information from sys.syslogins, and this will provide me a whole bunch of information on server logins. Some are logins that are user-created. Others are system credentials that we don't really control or care to control. And so we can still get information about me. I could do a search where the name is like Ed and get back a few things that are relevant to me. Nothing too fancy here. Other information provided could be the status of the login, the create, the update, last access, and so on. So again, lots and lots of information here for us to look through and learn about. You can also search for agent job information. MSDB includes a whole bunch of views that reference SQL Server agents, backup history, and a variety of other system data that could be useful if you're running frequent jobs, backups, or do other work with SSIS, for example. And so this is a little more complicated. So far we just talked about a few views, and they were by themselves kind of isolated. Here we have several views here. SysJobs tells us about the jobs themselves. SysServers tells us where they're running, and the job steps provides information on each individual step within the job. If the job is one step, you get one row. If the job is 4 steps, you get 4 rows back. Each step is a job. So if I were to select everything from this with no filters, use MSDB, we'll get back. I only have one job on my local server. It's not terribly interesting. Has 3 steps. I could filter, but again, only one job, nothing exciting. But a lot of information is provided here. In addition to the job type and ID and so on, we can find information about each step, the owner of the job, server it runs on, and as I scroll over, you begin to get the idea. There's a lot of stuff going on in here. Each of these views has a lot of information. It's unlikely you'll ever actually need all this information, but it's there. For example, for the steps themselves, under sysjob steps, you actually have the command itself that's being executed. The actual T-SQL is there. You can search that if you'd like. You can search the command, the step name. You can search the name, the description. So a lot of information here that we can go through and dig into and search through if we're interested. Tells us the database that it runs in. A lot of information. You can search link servers as well. For example, sys.servers gives us a list of all of our local servers we've defined. And if I run that, I discover I have a single link server. It's not terribly exciting. I could filter it if I'd like to based on name or perhaps data source. Let's add star in here just so we have some visibility into what the rest of the things are in these views. We can see a whole bunch of information here about what is it, where does it point to, what kind of link server is it, what's the data source, timeout information, so on and so forth. Security settings are here as well. Remote procedure settings are set here, modified date, so on and so forth. I'll do a couple more of these and we can move back and talk about some other views before we dig into the main thing here, which is how to tie it all together. Because so far nothing here is insanely complicated. We're really just looking at system data and kind of getting an idea of what's on our servers. So one last here one we can look at is, for example, server level triggers. If you have any triggers created in your server, you can get information about them. If I were to just grab everything without a filter, I find a single DDL trigger that I've created. It's kind of a dummy trigger, but it tells me the name of it, and the whole definition is there. The whole definition. I can copy it, paste it into a new window, and there's everything in that trigger definition for what's being returned. Then some more details on the type of trigger, and so on and so forth. And again, server triggers gives us the name of the triggers, and then the server SQL modules tells us the actual definition and details. And we can again filter if we'd like to on name or definition. or other things as well if you're interested. And again, only one trigger here to filter on, nothing too interesting. So that's kind of an overview of what the server level views look like and ways we can search and use them. Let's talk about some database level views. Everything we just saw refers to basically the whole server. System features, server settings, and so on that are global to your entire instance of SQL Server. But every database has its own set of views as well that tell us about that specific database and what's contained inside of it. So every database has one, system or otherwise, and it can tell us about the things we've created and done, such as schemas, tables, columns, stored procs, views, you name it. If you've created inside of a database, it's probably a view that can give you some information about them. They can get joined back to your server views to kind of link information about server and database. For example, if you have many servers you manage, you might be interested in kind of aggregating all this data and bringing it back to one place. Having that server level data would be useful for knowing more about where it's coming from. And again, we can use all this information to search and find out information about a database. If you have a specific application that uses one database, you can learn about all of the data and all of the schema definitions inside of that database and how it relates to your application. As with before, best way to really illustrate this is through demos. So we're going to jump back, scroll back down, go into AdventureWorks, and talk about database level views and things we can learn with them inside of here. At one of the highest levels, you can start just looking at schemas. Sys.schemas tells us about schemas, which are basically objects we create to categorize and add security to objects in a database. And if we look at all of them, we'll find out AdventureWorks has a bunch of schemas. Some are defaults, and others are user-created ones, human resources, purchasing, and so on. Some are roles. If I was interested in specific ones, though, I could search and say, hey, I'm only really interested in the ones that have the word person in them, which returns a single schema and some details about who owns the schema, that principal ID there. Pretty straightforward view. I include the database name here just for reference. You don't have to if you don't want to, but I find it's useful to have it, and we're going to reuse a lot of this later. So just adding in a little bit of metadata about the database name we're in, as well as what it is we're looking at. It's hard-coded, but it'll come in handy later. And that'll make sense in a little bit. Of course, where all of our data goes is in tables, for the most part. And so we can take tables, sys.tables, and join it back to schemas to find out what schema they belong to, and we can search on them. We select from this view. We get lots of information. I didn't filter here. If I were to filter on person, I get all the tables that happen to have the word person in their name. And so we find out salesperson, salesperson quota history, person, and so on. And what do we get out of sys.tables? Information about the create date, the modified date. In most Microsoft views, is MS ship tells you is it a default that comes to the server, or was it created by a user? There's some more information here that may or may not be useful to your applications, depending on what you're looking for. So now we can search for tables by name. That's also useful. We could also search for tables within a certain schema if we restricted it by schema name as well. Keep going and keep joining more things together. We had tables and schemas. We can move further and join tables to columns to schemas. So now we're going to get a list of every column in a given table, in addition to the schema information that goes along with it. For example, let's say I wanted every column in AdventureWorks that happens to have business entity ID name. This could be a lengthy list. As it turns out, there's a lot of business entity IDs in AdventureWorks. It's a big column for them. It's used in many places. There's 18 of them. And we can find out by joining these tables together, schema name, table name, column name. So now we know throughout this database, every single column that happens to have this name and information about them, such as the data type can be gotten here, the length of it, precision, scale, correlation if it applies, and so on, is it nullable. Lots of information here that we can take advantage of if needed. And we can search by the column name, the schema name, the table name, whatever you're looking for. You can search based on other criteria here as well. So now we're getting somewhere. We look for more obscure things if we want. We can search for synonyms. A synonym is really just a reference you create for convenience to refer from one object to another, between databases, between tables, so on and so forth. And if I search through here, I discover that I have no synonyms defined in AdventureWorks. How boring. We can filter on them if we want. But filtering on nothing, of course, returns nothing. So nothing exciting here, but again, it's worth including these sorts of queries in our analysis, even if they don't exist on my server. They might exist on yours, or they might exist on a different server that I manage somewhere else. And so including queries for things that aren't there isn't necessarily useless. It could be handy later. Indexes. Now I'll get a little more interesting here. So far, the things that we would look at are pretty basic. Give me the names of tables and columns. Nothing fancy. We could begin talking about indexes, though. Indexes are important. They affect performance. We like having the correct indexes in our tables. Good indexes help performance. Bad indexes can harm performance. So we want to know about them. If I grab everything out of the view sys.indexes, we'll join back to tables just to know what table they're on, I get a whole bunch of information back. I can filter on the index name. It provides all the indexes that include the name product category in them. I can learn a little bit of information here. Is it a unique index? What kind of index is it? And what details are there? Is it a primary key? And so on and so forth. So sys.indexes provides all of the basic metadata that describes an index. What is in the index and how does it work? Cool. We can take this further. That wasn't too complicated, but I'm sure some of you are itching for something more interesting. So we can look at our index columns. Knowing that an index exists by name is nice, but we probably want to know what the columns are within that index, the include columns, the key columns, because those are really important things to know. In terms of analyzing index, we can check for usage, but ultimately we have to know what is in the index and how is it being used. So this gets a little more complicated. This course is a little messier. I start off with the basic stuff from before, database, table, index name. I skip past that for one moment. We're selecting from sys.indexes and sys.tables. We're going to use some subqueries to grab the column information. So what am I doing here? We're taking a subquery, and we're grabbing data from tables, indexes, index columns, and we're having some where clauses here to join it back to our main query. So we're bringing everything back based on the ID of the index and the index ID and the column. Is it an included column or not? So for this scenario up here, I want to get all of the key columns into a list. I'm using XML here because it's convenient. There are other ways to do this. Feel free to use whatever method makes the most sense to you. For the sake of making this quick and simple, stuffing everything back through XML into a comment limited list is kind of the format we want, and it's convenient. If you wanted a set-based solution, you want to throw it to a table for analysis, you could. But for most eyeballing of this sort of data, having a comma-separated list is nice. And so we build a list separated by commas and go from there. And I do them in order, too. I include descending or ascending, depending on if it's a descending key column or not. And the order, of course, matters. So we order by the column, the ordinal, because the order of columns in your index matters greatly. If the order is different, it may not be useful. That's nice and messy. We do the exact same thing, almost the precise same query for the include columns. Almost the exact same query, except we check for is included column instead of is not included column. And then after putting that onto a CTE, we call it CTE index columns. We come back out and just grab the base data from it. Database, table, index, key column list, and then the include column list. Since it could be null, I just toss a blank in there if it's null for convenience for use later. And in this case, I filter. Again, we can filter by purchase order ID, for example. And I can not just filter the index name, I can filter based on the column list. I can actually say, hey, I want to know which indexes include columns or have key columns that involve this particular column name, or just a text string. So if I run this big pile of SQL from top to bottom, we come out with two indexes. There are two indexes in this database that happen to have this phrase, purchase order ID, in the column list. Or in other words, two indexes have purchase order ID in the column list. There's no includes, but there's key columns. This is pretty useful. I can search really fast on my server or in a database and find out, hey, is a given column in an index, or what indexes do certain things appear in, which indexes have descending columns, or PKs, or foreign keys, alternate keys, or unique indexes. So a lot of power here to learn about our indexes and how they're used without a whole lot of effort. On lines of obscure, we can look for things like service broker queues from the service queues view. And again, information about the schema that it belongs to, and some details about if it's a system one or not, if I created it, and some additional metadata. And look for foreign keys. Foreign keys are also useful. If you use foreign keys to track relational integrity, knowing what they are can be very handy to learn about your database. If a foreign key is used for every relationship, you can map your relationships using foreign keys and learn about them. Sys.foreignKeys is joined very similarly to sys.indexes above. And when I run this query, I get back every foreign key that has a name like customer. And so I get some foreign keys that link between customer and other tables, or sales order header, another table. I can get the foreign key name and some parent information and some other details over here about when it's created and modified and so on. This is starting to look a little familiar. Sort of repeat ourselves here, and that's good. Things are getting a little more familiar and easy to work with. Just like above, though, you're probably interested in knowing what columns are involved in the foreign key, because the name of the foreign key may have the column names in it, or it may not. It could be called test or something silly. You don't really know. So if we wanted to know the actual columns within the foreign key, we can do exactly the same thing we did above. We can write a big query that instead of selecting from sysindexes, we'll select from sys.foreignKeys, and then hit tables, schemas, tables, schemas to get the parent and the reference table, because a foreign key is a relationship. We want information about both the referencing table and the reference table. And then, just like above, we use the exact same syntax to put together a column list in a subquery. And by doing this, we go to foreign key columns instead of index columns, and the rest of this is very similar to before. And again, we're interested in knowing the foreign key column list as well as the referenced column list. We have two columns in our foreign key. We want to know both the names of them, the names of those same two columns, and the table that are being referenced by it, so we know the relationships. Kind of a bit of a query, but ugly as it is, it's not that bad in terms of what it does, and it's the exact same syntax as before. So if we're to run this big query, we can filter on the column list and say, hey, the foreign key column list or the reference column list happen to have special offer ID, return that. Give me information about it, because that could be useful later. So I run that. I get back two foreign keys. Here's the parent table information. Here's the reference table information. Here's the name of the foreign key that resides in our parent table. And here's the column list. And so we find out that this foreign key, for example, has two columns. And it refers to these two columns in the other table. Fortunately, the columns have the same names, but there's no restriction in SQL Server saying to design your database well. You could have columns that reference other columns with different names, or ones that seem irrelevant to each other. But this will provide the relational information about your foreign keys that you're looking for. And a few more things we can look at. Default constraints, for example. There's a view for those. So there's an app for that. There's a view for that. We can join default constraints to all the views we've seen already. Objects, schemas, columns. You can filter. And when we do so, we get some information about all the default constraints that happen to have quantity in the name or definition. And again, a default constraint can have a definition. It's more than just a 0 or a 1. Could have a lot of interesting stuff in here. In the case of here, it's 0 or 1. But it could be more. And we get more information, the name, the ID, details about the parent object we can join back to. It's pretty useful. There's all of our defaults. Do the same thing for check constraints. Sys.check constraints, well named, joins all the exact same views as before. I do a search for the word discount, and when I do so, I get back two check constraints. Again, parent schema, parent table, definition. It's getting a little repetitive, and that's good. So, just like server DDL triggers, you can look for database level ones. I can search sys.SQL modules, sys.triggers. Sys.triggers gives us the metadata. SQL modules provides the guts. And the guts is the definition. What's the trigger? I can find out if a trigger contains a certain table name or a certain phrase or other detail that you're interested in. And last but not least, the last search we're going to use is using that same one, sys.SQL modules, that actually includes a whole bunch of information in it. on stored procedures, filter procedures, views, triggers, functions, and so on. We can search that for everything all at once. We can do a case statement to find out what the object is, join SQL modules back to the object's references, including the schema. Then, of course, we can search, because I don't really want to get everything back. I want to search for objects that may contain definitions that have specific words or phrases or object names in them, or names that contain certain phrases. If I were to search for it, searching for the word purchase, now we're getting a whole bunch of types of objects at once. That's no problem. So we get back information. If there's no parent object, for example, it's a function, then we get nulls here. But otherwise, we can find out, hey, some triggers, a view, a function. Hey, a lot of information here. So that's the end of this piece of the demo. So now we've seen lots of views. Either you're very bored or you're waiting for what's coming next. Your choice. Let's take all this information, some of which was a little complicated, some of which is kind of simple, and bring it together to something useful. That's what we're promising all along, is something useful, and you're waiting for it. So let's not wait anymore for it. We can take all this and put it together. Realistically, everything we just did was a select statement with information about what are we searching for and what's in it. All that can be brought together. There's no reason we can't put that data into a single table and analyze it. We can customize our search based on almost anything you want. And by returning to one data set, we can actually look at it all as a whole. And you can say, hey, let's search my entire SQL Server, server views, database views, all the databases for a certain column or a certain object name. This can be extremely useful. We talked earlier about briefly why searching SQL Server could be useful. Now we're actually going to do it. And once we've written a SQL, we can put it all into a stored procedure, and we can make it reusable. And again, one important thing to ask here is how's performance? We're doing a lot of queries, searching a lot of views, doing a lot of work. How does it perform? And the answer is the more objects you have on your server, the more objects you're searching, the more objects in your databases, the slower it gets. But we're searching system metadata, so in general, doing this work isn't going to put a strain on your server. It's not going to cause your application to crash. It's not going to lock important data that an application is going after. So patience isn't that big of a deal here. If you're searching a lot of objects, it may take a little longer, but in general, there's no concern. So let's do it. Let's create a stored procedure that does all the things we just showed and more. So we're going to walk through this. I'm going to create an AdventureWorks so you can really create this stored procedure anywhere. We're going to call it Search SQL Server. The only parameter we pass in is search string. That's it. It's an nvarchar max, so it could be a very long search string if you're so inclined. Though in general, a very long search string could probably be a little interesting. So what do we do? So I can say no count on. We're going to pad our search string. I'm going to assume from the beginning that any search string we bring in is going to have the percents around it, and we're going to do a fuzzy search. You don't have to, but if we're searching a server for generic text, you probably want to know anything that contains it rather than things that only begin in it or equal to it. For example, if you're searching a stored procedure definition, you'll probably want to know if it's anywhere in the stored proc and not just in the beginning. So we're going to do a little bit of dynamic SQL in here in a bit, which is what a SQL command is for. We're going to make a database list, and we're going to get to work. This object data table is where everything's going to go. So I'm creating one generic table here that everything's going to go into. Not all the columns will be populated all the time, but this one generic table can hold everything, and when we return it at the end, we'll have it all in one place. So it's a little bit of a wide table, but the convenience factor is impossible to pass up here. And again, if you're searching less objects, if you have a very narrow use case for this, feel free to cut this down and get rid of some columns you don't need. For example, step names for a job aren't necessary if you don't have to search jobs. So we'll start off by getting a search of sys databases. We're already using a view to get our information about views. Kind of cool. So we'll get a list of all of our databases that happen to be online or offline regardless. We'll get the state and find out. And we'll just kind of store it as online because we don't want to try searching through databases that are offline. That'll cause some sort of fun error messages that we don't want to deal with. So now we'll start off. We have our table created to put our data in. We have a database list ready for in a little bit. So we can get to work. We can start putting data into our object data table. And I will demo this at the end, by the way. I'm not just going to walk through the proc and say good night, have a great day. So we're going to insert some information here. We're going to start off with jobs. We can do the exact same query as earlier that we looked at. And again, nothing new here. All these queries that you're about to see are things that we talked about in the previous script. Just now we're going to do insert, and we're going to organize data a bit and grab certain columns. You're free to add more columns if you'd like and grab more information. I'm getting the core data with the thought that once we search for and find an object, if we do need more information, we can go back later and grab it, and that's no big problem. So we'll grab our job data and put it into our table, our object data table. And since all the columns are nullable, I'm only going to specify the columns I care about in my insert list. And search string gets searched everywhere. So we'll check the name of the job, description of the job. We'll search the job steps for any job step. And again, this label here is going to be our object type. This is our own user-generated object type that will tell us at the end what it is we're looking at. Because if I throw this all into a table with no label, I don't really know what we're referring to. I might be able to figure it out, but I may not know. This is just this is a helper for us to understand what we're talking about. Same query as earlier. Search all of our job steps by command or step name. Search databases. See all database names based on name, search string, put it in. Logins, same deal as earlier. Search sys.syslogins for any login name like the text we're looking for, and put it into our object data table. And I'm starting to get the idea. This isn't getting any more complicated than before. We're really just taking the exact queries we worked with earlier and put it into a temp table. Link servers, where the name or data source for like a search string. And you can add more filters if you want. I chose the filters that made sense for me. But if other filters make sense for you, or some of these don't make sense, feel free to edit, change, remove, add, 100% your choice, customized to your heart's content. Server triggers, again, just like earlier, search server triggers based on name or definition. If you have a central management server set up, you can search those views as well. If you don't have any, then you'll get empty nothing. But if you do have something, you'll get data returned. Both server groups, servers. Now here's where it gets a little more interesting. Up until now, the queries we've been working with are pretty much the same as earlier. Just insert to a table the data that we got previously. But to get data for every database, we have to do a little more work. I'm not interested in just searching VentureWorks or Master or baseball stats. I want to get data from all my databases, no matter what they're called or how many there are. And so to do that, we have to iterate through our databases and grab the metadata from each database and bring it back into our temp table. This is going to require some dynamic SQL. I use a cursor. You can do this however you want. It doesn't really matter. The overall efficiency is about the same. So we're going to run through. And again, I'm going to make some assumptions here that there are no weird databases in recovery mode or anything like that that would possibly break this. If you have something like that, you have a bigger problem on hand that you should probably be dealing with. Your corrupt database, this probably is not the product you want to be running right now. So we're going to loop through one at a time. I'm going to create a SQL command. Within this SQL command, this dynamic SQL statement will be everything we talked about before, exactly as it was. Insert in information about tables from sys.tables. All the same information as earlier. We of course double quote our stuff because it's within dynamic SQL. And we add our search string. Capacities and parameter as well. However you want to do it is up to you. This is an internal DB maintenance sort of deal, and so we're not going to be exposing this to any users or anybody who's not a DBA. So I'm not too concerned about the structure of this, though feel free to alter and make it different based on your security standards or how you want to pass in parameters. 100% up to you. The real goal of this session is to provide the functionality. The implementation is 100% up to you. All that information about columns that we got earlier, exactly the same as earlier, tables, columns, schemas, exactly the same query as earlier, except we're in dynamic SQL. And because our temp table was created up above, before we went into this dynamic SQL statement, we can insert into our temp table. Our temp table is in scope. We can insert into it. That's perfectly fine. And again, search string. We can do it for schemas, just like earlier. Schema name search. Synonyms, just like earlier, by the name or object name. Indexes and index column references. Here's the giant index column query that we ran earlier in all of its glory, with all of the XML stuffing of columns into CSVs and everything. Take the CTE and just put an insert statement in here, and we're done. All the rest of the SQL is exactly the same, it's kind of red. Aside from being red, being inside of a string, it's the same as earlier. Service broker queues, Same deal, sys.service queues, exact same queries earlier. We can include replication. I didn't demo all these earlier because I thought that we got the idea and I didn't want to bore you too much. You can put replication in here. And so we can select from the replication articles and bring that back to our sys objects and get information out of it about what's the article status and what is the type and what's the name and so on. You can search for partition schemes in case you have partitioning. You can search for partition functions. You can search by the scheme name and the partition function name, database principals. So here are all the users within your database that are in there. You can search for those as well. Foreign keys, just like earlier. There's our query on foreign key names. Here's our foreign key column query. Again, exact same query as earlier, just a lot of red. And we're starting to get the idea here. I'm searching a lot of things here. I'm doing a lot of things on purpose because I want this query to do, this proc to do a lot. I want it to be something very useful that tells me everything I want to know. If there's something you don't need to know in here, take it out, comment it out. Default constraints, computed column definitions. Yep, there's information about that. Sys.computed columns. Check constraints, DDL triggers in the database, and then there are big SQL modules queries from earlier that got us information on stored procedures and views and DML triggers and so on. Here's that query as well. So all these individual queries, as we presented them earlier, for the most part, weren't too insane. We're now just putting them all together into one giant bunch of inserts into our temp table. And there we go. That's the end of our dynamic SQL. Whew. 500 lines of SQL later. Now we're ready to execute this thing and run it. And I do it in a try statement. The try catch is useful because it allows us to try each database, and if a database fails for any reason, maybe it's restoring or something's going on or maybe something changed in between when we took our original query in now, it won't break the whole thing. So it'll try the execute of the SQL to insert all that information into our temp table. If it succeeds, awesome. If it fails, we'll catch the error information, return it, but then we'll keep going. So we'll raise an error, which is awesome for us as DBAs, but keep going. We're not going to return. We'll end the catch and keep going. And so if a database fails, you'll find out why, but you'll still get all of your data back in the end, regardless of what happens. We finish up our loop. We get out of here. We clean up. And at this point, we're almost done. All of our information is in a temp table. Our server view data, our database view data is all in this view now. This temp table. It's a lot of columns, but ultimately it's just the stuff that we put in before in a variety of information. You select that information, give it an ordering, which you can alter depending on what you want to do, drop our table, and we're out and done. So we can create the stored procedure, complete it successfully. That's wonderful. And we can now test it. So I have a few examples here of execution. For example, I want to search my entire server for the search string pitcher. Probably going to hone in on my baseball stats database, which has all baseball stats forever. It's kind of big, useful for testing. We'll run it. You notice the results do not come back instantaneously. We're searching the entire server, but it took 5 seconds. It wasn't too bad. You could include additional parameters to search specific databases as an option, or do other various filtering to speed things up. Again, the customization is up to your desires. There's really nothing to stop you from customizing to make this faster or more useful for you. So what gets returned? 27 things on my server have the word pitcher in them. As expected, it's all in the baseball stats database because there are no pitchers and catchers in AdventureWorks. But here's some info on a view that I created, some information from baseball games about at-bats, pitchers who are batters, what hand they batted with, and so on and so forth. Data I imported, some log data. Kind of cool. What else can we search? We can search for business entity ID. This is a much more AdventureWorksy sort of search. If we search for that, it'll take the requisite 5 or 10 seconds to run, and it returns a variety of information. Here's a SQL table valued function, UFN get content information, and again I included the definition of the function. Some of these columns are null. Obviously the key column list of an index does not matter to a function, but it's useful to have the column there and separate our information. Stored procedures are here, such as these. We have some views, and again all the definitions are here for each object. We have columns, we have foreign keys, and now here come to play the optional columns. For example, for a column, there's a column name, a table name, a schema name, a database name, and that's about it. Could add some more information if you needed it about the column, but that's all I included. For a foreign key, we get our foreign key name. Cool. If a column happens to match the name of a search string, then we'll get that information. So index column, if business entity ID happened to be an index column, we'll get that information as well and learn, hey, here's some indexes that happen to have it as an include column or a key column. And then here's all the rest of the data. There's 104 rows here, so my search was not very specific, but enough to get a whole bunch of data back. Views, columns, foreign keys, triggers, et cetera, you get the idea. So that's pretty cool. And you can search for anything, and it may return server level data, database level data, or both, depending on what you're searching for. And that's the end of this demo here of the proc that we've created. We started off as a bunch of views and turned it into a useful proc. We put it all together. Cool. So with that, I'm going to kind of wrap up what we did and talk about it a bit more, and then move on to some questions, and we'll be all set. Now, I raced through it kind of fast, but it was a straightforward solution after we kind of talked about everything, and it's one you can download later, take home, and play with. So what was the whole point of this? Is we took a bunch of individual system views and a bunch of queries. Some were extremely simple and basic, things that you played with many times. Some were a little more complicated, and you may not have played with as much or even thought of writing, and put them all together into one giant proc. And this is a great example of how you can take a lot of simple queries and simple tools and turn them into something really useful that can be used in development, could be used in production, that could be used for research, and for a lot of other purposes that you may have that I may not have. There are a lot of things I didn't include here. There are a lot of features in SQL Server that have views or dynamic management views for them that are useful for partitioning, in-memory OLTP, resource governor, always long, you name it. There's potentially a view for it. You can get information on reporting services or integration services, packages if you're so inclined. Views exist for all this and more. Look it up online, check it out. If a view exists, all you really have to do to make this extensible is either on the server level, up top in the stored procedure, add some more inserts into the object data table with the data you want, or move on down to our dynamic SQL section and add another section where we insert into the table in here. And so you can add to the stored procedure or remove from it very easily by simply deleting some SQL or commenting it out, or adding some more inserts. And if you make a mistake, you can fix it pretty easily. It won't break everything that's already there. The key to this, though, is to customize. This is a tool, and it's a free tool you can build on your own and do whatever you want with. This is stuff SQL Server includes with the installation. It's free. It's awesome. You can play with it at no charge to anybody. Just have fun with it. So customize. Make it useful for yourself, your development needs, your business needs, your production needs, and run with it. There's no reason not to. And so I think I've talked enough. I've presented interesting solutions that I like and that I personally use all the time at work, at home, in presentations, and I like. And so given that, I think it'll be great to open up some questions. If anybody has any questions on what I've presented, the T-SQL, or about what I've done.
So we have a few questions for you, Ed. The first one is, could you possibly send me a zip file with the scripts for the queries and maybe the stored procedures where I could post that on our website?
Yes, I will email this back to Pass afterwards, and they will post everything, and I'll also include it in my Twitter as well, just for convenience. If anybody wants to grab it off there, I'll put links to the files there as well on Dropbox.
Yeah, and there was a comment about the breadth, considering the breadth of what was being searched. It seemed really quite good performance, for that big one that you did. And then the other is, are searching the...
Actually, we'll comment on that. There is, it's worth mentioning that my local server only has a handful of databases on it. It will be slower on a bigger server. I will warn that. It isn't a bad thing. It isn't a bad slow, but it will be slower. And again, you can filter further to kind of reduce the amount of work you have to do if you want.
And are searching the system views, is that the only way to know the bottlenecks for performance tuning, or which method do you suggest?
So what we did here is we searched mainly for research and education. So we're searching our schema to learn about what's there. So learning about what indexes there can be useful towards tuning indexes. For actual utilization, though, there are dynamic management views out there that provide information about how much your indexes are used, or statistics, or details on disk space usage and so on, or the buffer cache usage. Those are other views that we didn't look at here. Our goal here is to talk about schema and what's defined in the structure of your database and your tables, and your features and your server specs. If you're interested in just that, this is perfect. If you're looking for more information, though, about how features are used, for example, index usage, there are other DMVs out there you can use. I've done presentations before in the past. Feel free to look them up. You can hit me up on Twitter if you want some links. I'm sure Pat has had other demos before and presentations on it as well. So there are other tools available in addition to this that will give you further insight into usage of your server and optimization techniques.
Another question is, what levels of SQL Server contain all of these views? Is it on all versions as well as, like Express Standard, Enterprise?
Yes. Any version of SQL Server, now it goes back, obviously go back far enough in time, SQL Server 2000, there'll be some things that don't exist, but these views are tested and work in 2012 and on. If you have an enterprise version that has every feature, you'll get information back. If you have a version that is not enterprise, you'll get nothing back because you may not be able to support the feature. But every version, every edition will have these views available to you. Whether they're populated or not depends on what you use within that server.
Are you going to watch all this over? What is?
Got a stumper coming?
Yeah, no, I'm just reading through. I mean, we mentioned that we will be getting the scripts to post on the website, and do you have a blog that talks about other DMVs? He is going to put on the Twitter. Do you run?
Yep. If you're interested in more, I've done articles on similar things in the past. I've actually done articles more specifically on the views, digging into them further, and using them for other research. I'll have links at the end of this presentation. You can download, go to them later. That go to SQL Server Central, SQL Shack, and my Twitter, and places I've posted articles to. Feel free to explore beyond this presentation if you want and get more information. But I think I have 3 articles in the past, or 4 in the past year, on just this topic alone. Feel free to go to them, play with them, and let me know if you have any questions.
Have you run into any data anomalies where the queries seem to miss data?
In the past, yes.
In the
past, I have fixed them.
Sorry,
go ahead.
Or is it addressed by your use of is null? We've run into some confusing results.
Okay. As far as I can tell, there are no data problems here. That doesn't mean that I didn't miss something. This is a query that I've written, and I've used it a lot and fixed bugs before. It does not mean it's bug-free, though I hope it's bug-free. If you happen to find a bug where anything's missing that should be there, feel free to let me know. Again, the actual where clauses in many of these queries are things that I put in there. I did not check everything. I often check name or definition or column list. If there are other columns you want to search on top of that for further information, feel free to add more where clauses to make it less or more restrictive based on what you're trying to do. And that might help out if you do see you're missing something. I believe I've handled null pretty well here. And then each data set is inserted separately. There's no joints between them that could aggregate and destroy that data, as far as I can tell. If you want anything funny, let me know, please.
And what SQL Server permissions do you need to run these scripts?
For database level views, you're going to have the ability to view schema within the database, so DDL, admin at most, or at least the ability to view definition on database objects. Many of the server ones require view server state or similar permissions. Again, you can try it out to verify if you have the permissions or not and work through them if necessary. But generally, DDL access is what you need to view these. So server level is view server state, database level is DDL admin or a similar permission that gives you access to those views.
That's about it. The only other comment is if you could put up a slide with your contact information.
Oh.
Or,
sure.
Yeah,
I have it right here, actually. And again, if you want the links, feel free to download and click on them later, or just Google. I mean, Google grabs everything and you can find out where things are. But links are right here if you want them.
That's great.
And I put a plug here for SQL Saturday Albany. That's my baby. If you live anywhere near Albany, New York, or in the capital region and want to come to a cool conference, we do one near the end of July every year. We just wrapped up our third this year. So if you feel like coming and having a good time, I'd like to have you. Nice over the summer here.
Well, that's great. Well, thank you very much for your time, Ed, and for the presentation. And like I said, this will be, it is being recorded. It will be posted later today or tomorrow up on the Virtual Chapters archive page, and we'll get a copy of the scripts and also attach those. Thank you again, Ed, for the presentation and your time.